Okay, here is the Chapter 2 test review again, but here we're starting with number 7. So y equals x squared plus 5. We are testing for symmetry. There are 3 areas of symmetry that we need to test. We need to test for the x-axis, where we plug in negative y. We test for the y-axis, where we plug in negative x. And then we test for the origin, where we plug in negative y and negative x. So when we plug in negative y, we will get negative y equals x squared plus 5. And essentially what we want to do is we want to be able to test for symmetry. We want to try to get what we have here from plugging in negative y to look exactly the same as our original problem. And if we can do that, or if it does happen, then we have symmetry. If we cannot do that, then we do not have symmetry. So to get from negative y to positive y, there's only one thing I can do. I can divide by negative 1. So if I divide everything by negative 1, what's going to happen? I get y is equal to negative x squared, and that negative is not with the x being squared, it is actually separate, and then minus 5. So I can't do anything about getting this back to x squared plus 5 without multiplying by negative 1, which would then just get me back to where I started. So there is no symmetry with respect to the x-axis for this equation. Testing for the y-axis, we plug in negative x. So we're going to have y is equal to the negative x is going to now be in parentheses squared plus 5. Well, if we clean this up, the negative, when we square it, is going to become positive. So we can identify that this is just going to be positive x squared and then plus 5. And right there, we have exactly what we started with up there. So we do have symmetry with respect to the y-axis. And now we test for the origin. So we plug in negative y and the negative x, and we see if we can simplify this out to get back to our original problem. And again, the negative within the exponent of 2 is going to become positive. So that will give us negative y equals positive x squared plus 5. This right here gets us right back to where we started when we tested for the x-axis, and we know that it didn't work there. So in this case, it's not going to work here either. So no symmetry with respect to the origin, no symmetry with respect to the x-axis, but yes, there is symmetry with respect to the y-axis. We have to test all 3 of those for each one of these. Okay, so I'm going to draw some lines here just to give us some a way to identify what we're working on. All right, so the x-axis, I'm going to plug in negative y. So I'm going to have x is equal to negative y in parentheses to the 3rd power. Well, if you take a negative number and cube it, you still have a negative number. But if we plug in a positive number, that stays positive. So there's no way to get rid of that negative. So this is going to just be the negative value of y cubed, which is not what we want because we can't get rid of that negative. So there is no symmetry with respect to the x-axis. Now plugging in negative x. If I plug in negative x, I have negative x equals to y cubed. The only way to get rid of that negative x is to divide by negative 1, which would just get me x equals negative y cubed. So no symmetry with respect to the y-axis. Now let's test the origin. I would plug in negative x and negative y. Okay, first we'll start with this because it's inside parentheses. We saw up here that the negative for the y is just going to give us a negative y cubed. But this time we have negative x also. So if we divide by negative 1 here, we will actually end up with x equals positive y cubed, which is exactly where we started. So we do have symmetry with respect to the origin in this case. Testing for number 9. For the x-axis, we're going to plug in negative y. So we get x equals negative y squared minus 1. A negative being squared is the same as a positive, so x equals positive y squared minus 1 is exactly what we started with. So we have symmetry with respect to the x-axis. For the y-axis, we're going to plug in negative x. That will give us negative x equals y squared minus 1. If I divide by negative 1, to get x to be positive, I will get x equals negative y squared plus 1. I can't get that back to the original equation, so no symmetry with respect to the y-axis. And now we're going to test the origin. So we're going to plug in the negative x and the negative y. The negative y will be squared to be positive, and that will give us negative x equals y squared minus 1, which is exactly what we had when we tested for the y-axis, which did not work. And so I could highlight this and understand that this is also no. And that's how we test for symmetry. And now on to circles. We want to write an equation of a circle that satisfies the given conditions. We have to remember that circles use the equation x minus h squared plus y minus k squared is equal to r squared, where h and k are the center, and r is the radius. So as long as we can find the center and find the radius, we can write our equation. So here we are given the center and the radius. So all we need to do is identify where to put them. Well, the center is h and k, so 4 goes in for h and negative 1 goes in for k, and 5 is our radius, r. So we just have x minus the 4, and that's squared, and then y minus the negative 1. Well, y minus negative 1 is the same as y plus 1. Y minus negative 1 is y plus 1. So y plus 1 squared, and then the radius, 5 squared. So we get 25. And that's our equation. We don't want to square this. We don't want to change this. We're done. For number 11, we are given the center, h and k, but we aren't given the radius. But we are told that the circle, here's the center, 3, 2, our point way over here is negative 9, 7. So if we could find the distance between those 2 points, that will tell us the length of the radius. So we have to find the distance between these 2 points. So for our work on the distance formula, I'm going to label these x1, y1, and x2 and y2. And for my distance formula, or our radius, I'm going to find the distance by doing x2 minus x1, so negative 9 minus 3 squared, and y2 minus y1, so 7 minus 2 squared. This is negative 12 squared, which is 144. 7 minus 2 is 5 squared, which is 25. And 144 plus 25 is 169. So our radius is 13. Now I have h and k from the beginning of the problem. Now I can just write my equation. So x minus the 3 squared, y minus the 2 squared equals our radius squared. So 13 squared is just that 169. And there's our equation of that circle. Now, we need to show that the equation for number 12 represents a circle. So we need to somehow try to make this equation look like one of the two from 10 or 11. So what we need to do is we need to group our variable terms. So we have x squared minus 6x. We also have y squared plus 4y. This 3 right here, I'm going to add to the other side to get 3. What I want to do after I group these is complete the square. Because when I complete the square, and I have a perfect square trinomial, I can write a factor similar to what I have here to be something squared. So I'm going to complete the square. So to complete the square, I take 1/2 of this x term, so 1/2 of -6, just the number, and that is going to be -3. This -3 is what is going to go in for my factor, and I already really know that that factor will now be x minus 3 squared. But I need to finish this problem up because whatever I add here and here, I'm going to add to the other side of the equation. So I can't just forget about that. So -3, when I square that, I get 9. I'm adding 9. And then over here, y squared plus 4y, 1/2 of the 4, positive 4 in this case, is positive 2. So for my y, I am going to be, I am going to have y plus 2 because that's what I have there is y plus 2. And that is squared. So, but now 2 squared to fill up here is 4, and I'm going to add 4 over there. And now I'm going to simplify this, and I get 9 plus 3 is 12, plus 4 is 16. So I was able to get to an equation that is in the same format of our equation of a circle. I also need to find the center and the radius. And if the center is hk, and I have to think about x minus the h squared and y minus the k squared equals r squared, I need to look at the formula and how it matches up. This is x minus a 3 and x minus an h, so the 3 is the h. These are already in the same format, so minus and minus. So all I need to do is take out the 3, and I know that is my h value. Now in this case, for the y, this is positive, this is negative. So I need to rewrite the y plus 2 to be y minus a negative 2 so that I can compare these formulas accurately and identify k as a negative 2. So k is negative 2. So there's my center, 3, negative 2. Now r squared is equal to 16. I'm trying to find the radius, which is just r. So I'm going to square root, and I get r equals 4. I don't need negative because the length of a radius cannot be a negative 4. So here my radius is 4. Okay, so I had the equation written out, which is now all messed up here, but I had the x minus 3 squared plus y plus 2 squared equals 16, and then I was able to find the center and the radius. So I will end this video and do the last page on a separate video.